Everyone, in this video we are going to be discussing how you can manage different versions of Python using Docker. Now what happens is when we are working on a project and we have certain features from one version of Python and certain features from another version of Python, and it gets really difficult to manage those. Although there are uh, other methods such as virtual environment, and you can do this same exact thing using virtual environment as well. But what I have felt over the years by utilizing Docker is that when you use Docker, you can quickly test certain things and you don't have to install anything. The only piece of software that you need is Docker. Okay, so let me show you how does this look like. Okay, so first of all, I am inside this home directory. Let me navigate to although navigating is not required, but let me show you how you can also run the script as well. But let's first start simple. Okay, so projects, experiments. So I have bunch of files here. Now what I want to do is I want to start Python here. Okay, so how can I do that? First, you need to install Docker. Now I am on Mac. What I have done is I have already installed Docker. So you would need to install this Docker for Mac, and if you are on Windows, you would have to install it for Windows, obviously. Now, when you install it, what you get is you get two different sets of features. One is Docker daemon. Now let me show you how does Docker daemon look like. Okay, so I have already started it. So this is the Docker daemon. Now this Docker daemon, what it does is it basically runs certain things which makes Docker possible. Okay, now I can cover what Docker is and what features Docker has in another video, because uh, it will basically take us away from the topic of this discussion. Okay, so it starts the Docker daemon, and you see this engine is running on the lower left. The moment this is succeeded, this installation, you will also get a Docker command line. If I print Docker here, you see all these bunch of commands that we can choose from. Now after installing both Docker client and Docker server, you can say, you can also call this as Docker server or Docker daemon, whatever you want to. Now what I can do is I can get all the different kind of versions of Python. Let me pull up. So I will say not pull but rather run, or let's use pull first. So what pull allow you to do is pull allow you to pull images, and in Docker terminology, image is just an artifact which has both operating system and the runtime. So here runtime is Python, and it can be used not just for Python, other services as well, such as Node, Nginx, and things like that. Okay, so let me pull up Python and let me specify the version 3. Let's say 9. Okay, if I hit enter, it will ask me to allow this download, and it will start the so pulling from library Python. So it is pulling this image. Now if I go here, currently if I look at my images, I have a Python image, but it was of different version. Okay, so that's why it has to pull this image from the internet. Okay, I'll also show by pulling one another image and how to work with it, but let's bear with me. Okay, so what essentially it is doing is it is pulling this image in layer by layer. Okay, now this layer can be defined using what is known as Docker file. Okay, now this Docker file is maintained and created by the developer of this image. Okay, so that person is responsible for creating and managing this, and what that person must have done is he must have defined these layers, and here the the Docker client is trying to pull these different layers. The moment this is done, we will see a Python's version appearing here. and what we can do is we can work with that image. How? So what do we mean by working with that image? What we mean is we can essentially um, run Python code within that image. How do we do that? We do that using something known as containers. Okay, so the running instance of an image is known as containers. Okay, so image is just an artifact. If you run that image, you create what is known as container. Now container, you can think of containers as its own different operating system. Within that operating system, it has file system, it has networking and things like that. Okay, so now we have installed this image. Sorry, not installed, but pulled this image. How can I run it? Let me run it. If I specify the name, or also I can say docker images. So I can see I have got two Python images. Now let me run this image. Okay, notice what will happen. I will have to specify the tag as well. So the moment I run, nothing happens actually. Now why it doesn't create anything? Because uh, when the developers of this image must have created a docker file for this image, they must have specified what will be the command that will run when the user runs this image. Okay, and that command must have waited for the user input and it must have not got it. That's why it just exited. So to solve this, what we can do is we can run this image in an interactive mode by specifying this it command. And if I run now, you will see I am now entered in this Python's IDLE, and I can do bunch of stuff. I can import package, but now I'm not using this Python from my Mac's Python. It is Python inside the container, and this container do not know what my Mac has. So my Mac has certain files also. So for example, I'll show you what I mean. So let me exit out of it. Let's say my Mac has these bunch of files, right? Now if I go inside the container again, you see again we are inside the container, and if I open OS, let's say, or maybe some other packages, I won't be able to see these files. How can I know I won't be able to see these files? In Python, how can we list the directories? So let me show, or maybe os dot, let me see, get os dot get, do we have any let me see, os get current working directory. Okay, get cwd. So get cwd. So you see, this is the current working directory, which is completely different than my Mac's current working directory. You get my point, right? Within this current working directory, I have nothing. So it's like a very simple Linux-based system on which I have got this Python. Okay. Now, if I exit out of it, let me show you something else also. Now, after running this in an interactive mode, what I can do is I can just get rid of this command, and I can run a script from it. Okay, so I have basically started a Python. Now this time, after specifying the image, what I can do is I can specify the command. So I want to run Python inside this container. So up to here, I'm just running it. Now I'm overriding the command which must have been written by the developers in the Docker file, and I'm specifying what file I want to run. Let me specify app.py. So if I hit run, you see what happens. Why does it happen? Because after this step, we are inside container. Now this Python inside the container does not have visibility into app.py. Although you see app.py currently exists here. Now how do we resolve this? We resolve this by creating something known as volume mounting. Okay, so how can we do that? So what we do is, after doing this Docker run and before specifying the image name, we can pass this argument called v, and this v, in v what we can pass is we can say to the container, to the running instance of container, that hey, take the host system's file directory and put it inside a certain folder, and that certain folder we can define. So what I'll do is I'll use print working directory. So current working directory I'll take. So this is my host machine which is hosting this containers directory, and I will specify colon. After colon, it will tell us the directory in which I want to kind of mount these files into this. So I will specify this as app. Okay. Now, if I run this, again it will fail. And I'll tell you why it will fail. Let me run it first. Okay. You see, can't open file app.py. Why? Because even though I have mounted this directory inside the app, I have not changed my directory here. Now, how can I change it? So what I can do is, before the image name, I can also specify my working directory by passing this w parameter. So now I'm changing my directory before running the image. And now if I run the app.py, it ran, right? So function, so this was the code that I basically prepared for this demo. Okay, so there are bunch of information that I just described. First is this volume key, and then there is this working directory key. Okay, now this python is basically hosted in a Linux machine only. Okay, so what we can do is we can get rid of this command. I can instead open a bash here. So although I am getting the Python image, but Python image is built on top of bash. So sorry, not bash, Linux. Very slim version of Linux. So if I hit enter, nothing is happening. Why? Because I did not run it in interactive mode. So let me run it in interactive mode now. So I will come here and I'll specify this as interactive mode. So now that see that I am inside this bash terminal, and I am inside the app. Now if I list the directory, you see all the files which were there in my host machine are inside the container now. I can write down all bunch of stuff like cd into, I can cd into some directories or things like that. I can make directory. And also one thing, if I make directory here, now that will be reflected in my host machine also. For example, directory from Docker, from container maybe. Now this will be visible there as well. Okay, so now let me exit out of it. And if I list now, you see directory from container, which means any work that I do within my container will be now visible. So I think we have covered a lot, but I want to showcase one use case which is quite powerful in my opinion. So suppose you want to test certain features of the new versions of Python. How can you do that? You have to install, maybe create virtual environments, or maybe install new version of Python and things like that. But with this, what I can do is also one thing that I want to show is, if I go inside the container, you see all these bunch of containers appearing. Why? Because by default, if I stop the container after the use, it does not delete itself automatically. Can I enforce it? Let me show you something first. So if I just do docker run, nothing of this sort, Python 3.9, the moment nothing is here, right? If I do enter, now you see this container is created and it's not deleted. But if I add this argument called rm, which means it will remove it after the use. If I hit enter, now you see nothing is created. Why? Because it was automatically removed. So if I delete it again, if I run it again, you see nothing is created, right? So this rm is handy. Now with this rm, what I can do is I can launch the Python. Let me show you something. So I can launch the Python inside this container. Okay, interactive mode I need to activate. So I can launch the Python, and let me show you something. Suppose I want to test out certain features. For example, in 3.12, there is this feature that I can use double quotes inside f strings. So suppose I have a dictionary called person, which has a name of Rahul. Now, if I, let's say, use f string, my name is, then I would have to do something like this. So I would like to pass person, and I will have to use single quotes. Why? Because my this quote is starting from double quote. So I will use name, and you see my name is Rahul. Now if I use double quotes here, it will fail, right? It is failing. But let me do one thing. Let me open a new terminal, and now what I'll do is I'll copy paste this, Control C and Control V. But instead of 3.9, I will open 3.12. Now I have 3.12. See how easy it is? Obviously, it will take some time, first time, to pull up these images. That obviously is going to take some time. So now that I have these images, it's really quick. So after that, I would like to define this person again. Okay. Now I would like to print this. This will work fine. This will work fine. This worked fine before as well in 3.9. But now this is also going to work fine, because that this is the feature that was introduced in 3.12. 1 second, sorry. I think I copied extra stuff. Okay. So if I hit enter here, you see this did not throw any error. Why? Because we are inside the 3.12, and I find it really easy. Now what will happen is the moment I exit out of it. So currently if I see my current my containers are running, but if I exit out of it, one of them will be lost. 1 second. If I exit out of it, one of them is gone, and this one will also be gone when I do exit here. Okay. So yeah, so this one is also gone. So this is one of the primary use case of using Dockers and managing Python, different versions of Python. And there are a lot of things that we can do, not just managing versions. We can run scripts with it. We can create virtual environments within these different versions of Python, and create databases, services. And this is not just limited to Python. We can do it also. We can do it also for other services such as Node, HTTP servers, creating those servers and things like that. Okay. All right. So I would like to stop right here. Please let me know if you think anything else can be explained in a better way. Thank you.